This is Jeff Mucci with RCR Wireless News. I'm the editorial director, and I want to thank everyone for joining us today. Our clock shows that we've got a couple minutes before 1 o'clock Central Time, but we want to go ahead and open up the call and let everybody know we're here. So we'll be, I'm actually going to turn a poll on and ask folks to vote on it while they're joining, and then we'll start the webinar promptly at 1 o'clock. The poll will help us understand a bit better who's on the call and some of the concerns you might have about narrowbanding.
It's not TDMA. Don't have it on.
So we just added a poll up there. We'll keep it up here for about a minute, and then we'll start the webinar with an introduction to our speaker, David Witkowski from Anritsu. We have almost 500 people register for this webinar, and please, as you join the call, please take a minute to select one of the options on the poll, which is what's the biggest challenge you had to overcome or expect to overcome if you've not completed a transition to narrowband. And again, this will help us gauge the audience sentiment a bit, and our editorial team at RCR will use this information to be more insightful about narrowband as an issue. Okay, we've got almost 70% of the people have voted on the poll, so I'm going to go ahead and start with an introduction and leave the poll up for a few more minutes. But thank you again for joining today's webinar on test and measurement solutions for narrowband. We're delighted to have a true wireless expert on the call from Anritsu, David Witkowski, who's a product manager for Anritsu. He's also president of the Wireless Communications Alliance in Silicon Valley. David, thank you so much for joining us today.
Good morning, good afternoon, as the case may be.
I'm going to close the poll now. I'll give everyone a few more seconds to vote, and then we'll go ahead and close the poll, share the results, and I'll turn the microphone over to you, David.
Okay, thank you.
Okay, so share the results here, and so what is the biggest challenge you had to overcome or expect to overcome with respect to transitioning to narrowband? And outdoor coverage looks like the lead, and followed by locating and managing interference sources. So David, I hope that helps you as you go through your presentation. Today's format will be a 45-minute or so presentation followed by Q&A. We'll have another poll at the end, a few administrative items. If people have questions during the call, you should see a questions button on your screen. Please feel free to submit those questions during the call. We'll be monitoring those and prioritizing those questions, and either trying to answer them throughout the presentation or holding them till the end of the call. If you have questions on sales or whatnot from Anritsu, you can call David. I believe it's 1-800-ANRITSU.
That's correct.
Okay. So I'm going to hide the results now from the poll, and David, turn it over to you.
Okay, thanks, Jeff. So good morning and good afternoon to everybody on the call, or if you're calling internationally, good evening, whatever time of the day it is for you. I'm David Witkowski. I'm product manager for Anritsu, and one of the products that I am responsible for is the Anritsu S412E LMR Master. I also do some other products within the company. But today's focus is going to be on test and measurement solutions for narrowbanding. We'll be talking about what is narrowbanding, which I presume that most of you already know what that means, or you may not have registered. Then the problems that we deal with specifically how narrowbanding isn't a plug-and-play migration. There are some things that we need to address during narrowband transition. The causes of the problems that occur during narrowbanding, the things that can and do go wrong, and we'll talk about some solutions for mitigating that. I appreciate all of you participating in the poll. I think that tracks well with what we have seen in the industry and what we know are the challenges, so it's good to get that validation. First of all, talking about what is narrowbanding. There's a mandated deadline for narrowbanding, which is 11:59 p.m. December 31st of this year. It affects most VHF and UHF licensees that are governed by Part 90 for land mobile radio. And in narrowbanding, the current 25 kilohertz channels that you occupy must migrate to 12.5 kilohertz channels. And this can be a migration from either analog to a narrowband analog, or also analog to digital. And there are some various choices that are available if you're making the migration from analog to digital. And if you are moving to digital, there are some specific challenges that you need to focus on. We'll talk about that during the call. If you look, going back, a very cursory search that I did on Google, going back only 6 months, yielded a huge number of results in which I was looking for cases in which radio systems had failed. And there were reports in the media of radio systems that had failed because of their transition to narrowband digital. And we'll talk specifically about 3 cases on this list, but this is by no means definitive, and I didn't dig very hard to come up with these. And as you can see, there are quite a few places where people have tried to make a transition, and there have been issues that have been significant enough for the local media to report on them. In some cases, it's just simply an annoyance. In other cases, the system has performed so poorly that they have actually had to go back and do major mitigation to solve those problems. And so, you know, because lives and property are at stake, and I want to point out that this list that I'm viewing right here is related specifically to public safety. So this does not even address the people in the commercial, the industrial users of land mobile radio who have experienced problems, and that has a potential effect on their business and their bottom line. So one of the 3 cases that I'll talk specifically about is the military fire system, which has been widely reported, especially in the New York area, where the radios that the military fire department that covers places like West Point has had major issues with their digital radio system. The other one here in Northern California, Oakland, California, had a major problem with dead zones. And for those of you who are familiar with Oakland, you know that it's a place where the police department is critical. It's an area that tends to experience a higher volume of crime. And they had a case last year where they were chasing a person who was suspected of murder, and they lost him because the radio system did not work, and they were unable to communicate, and the person was able to get away during a high-speed pursuit because the radio system was not performing. And then one of the more famous cases where indoor coverage, the ability of the radio system to work inside of a building, came up was at JFK International, where the Port Authority police were, after they had put almost $1 billion into a new terminal at JFK, the Port Authority, which is the police force that covers the airport, discovered that their radios did not work inside the new terminal. And we'll talk about some of the reasons why this occurs later on during the call. But indoor coverage is sometimes just as important as confirming outdoor coverage, and in some cases it's actually more important. I'm going to go into discussing failure causes at this point. The primary cause of failure for a land mobile radio system, if you're making the transition from analog to digital, is the erroneous presumption that your analog coverage is equivalent to your digital coverage. A lot of manufacturers make a big deal about the here what they call the digital improvement, where you have a quality which is better than analog for certain levels of signal strength. The problem is that in this area down here, there's what's called the digital cliff, and that means that a digital system works very well up until a certain point, and then it just simply stops working. In an analog system, the human mind has a great ability to hear around interference. So if there's static on the call, or rather, if there's static in the transmission and you miss a few words, it's not a big deal because your brain is capable of supplementing that information. And whereas with the digital radio, if you lose the signal, the processor in the digital radio simply shuts down and stops working, and the audio that's coming out of the radio simply goes away, or it becomes unintelligible. And so things like what's called picket fencing in the analog world, where you get a fast chop as you're driving in a poor coverage area, becomes a multipath problem in digital. And there are some recommendations that have been put out by TIA, particularly TSB 88, which recommends testing BER and what's called DEQ, digital audio quality, but it does not mandate the use of what's called modulation fidelity, or error vector magnitude testing. And the problem with that is that BER and DEQ don't directly account for multipath. So modulation fidelity and error vector magnitude are the ways to directly measure the effect of multipath, but because they're not mandated, a lot of times those tests are not performed. So in this area here where you have low signal strength and you're on the fringe coverage, this would equate to essentially a shrinking of the coverage area that you currently have with your analog system. And because of that, you have to work around that. You have got to reconfirm coverage, particularly at the fringe areas of your current service area. You can see here that if you try to correlate RSSI, received signal strength, to bit error rate performance, that the correlation is very low. For various levels of RSSI, you can have a wide variety of bit error rate that occurs in the receiver. Whereas if you correlate between bit error rate and modulation fidelity or error vector magnitude, you can see that the correlation is a lot better. You're getting a definitive band of results here for different levels of error vector magnitude. So what we're saying here in this slide is that you can't just test signal strength and presume that it correlates to bit error rate performance, because at the fringe areas of coverage where you have low RSSI, that's just simply not the case. In the digital land mobile radio, things that are annoyances become jammers. For those of you who use land mobile radio, you know that a lot of times you pull into a gas station and they have the point of sale terminal, the uplink dish on the roof, and that tends to emit a lot of noise in the land mobile radio bands. And that becomes, in analog, it's an annoyance. You turn the volume down or you turn the squelch up. Things like door sensors outside of shopping malls or grocery stores can also generate noise. And all of these things are things that in the past we've simply worked around by ignoring them or tolerating them. But imagine that you were parked outside of a grocery store or at a gas station and you are on a digital system. It could be that your radio just simply stops working, so you may not hear the call. And you need to make sure that these critical areas are covered. So these are, when you do a digital system, you need to put a lot more thought into the potential sources of interference, and instead of just tolerating those annoyances, you have to go back and work around them. The other thing that occurs is that as we've seen a proliferation of digital land mobile radio standards, these standards do not interoperate. So there are cases where, based upon weather or propagation, signals could go from one part of your state to another. Here in the Northern California area, for example, we occasionally get propagation in the South Bay, down in the Silicon Valley, from up in the Sonoma, Napa area, what's sometimes called the wine country. And depending upon the weather, you can sometimes get very strong signals. Now, because we all share a spectrum, imagine what would happen if you had a P25 system in the South Bay and an NXDN system running in the North Bay, or even if you had a P25 system in the South Bay and an analog system, narrowbanded in the North Bay. You would hear noise, or you could possibly have interference significant enough to prevent the digital system from working. So we have a proliferation of digital standards right now in land mobile radio, and it's based upon the propagation at the moment. It could become co-channel interference, in which case you wouldn't necessarily just hear the other, you're not going to hear the other station, you just wouldn't hear anything at all. So you may not even know that the interference is there. In public safety, we have a proliferation of complexity, and this is of course occurring even in the commercial world as we fill our cars with portable radios, GPSs, two-way radio, cell phones, computers, 4G data cards. All of these things can potentially interfere with each other. In the public safety world, you have this as well, and as you can see from the photograph here, this police car has been jammed full of everything under the sun, and then each one operates at a different frequency. You also have cases where you have a data radio that's working on perhaps Wi-Fi, WiMAX, or now that we have 700 megahertz public safety LTE, this will become increasingly a challenge because these data radios transmit blindly. They simply transmit when they need to. And it may be that those transmission could interfere with digital voice radios that are in the car. So if the laptop begins uploading a report or downloading a dispatch, then at that moment it could possibly be that the voice radio would be interfered with to the point where a call would not come through. So we need to really focus heavily on spectrum management, channel management, and spectrum clearing to make sure that these cases are not going to occur. I talked a little earlier about indoor propagation or indoor coverage being a major problem. At JFK International, this was something that actually was not even anticipated. So when they commissioned the new building, they didn't realize at the time that it was going to be a problem, and they got into the building and suddenly realized that they had a major issue. One of the things that occurs, of course, here in Northern California was we reinforce our buildings quite heavily for earthquakes in parts of the country that experience storms, Hurricane Alley or the East Coast, where they get a lot of big storms. Of course, the buildings are reinforced to deal with that. And then as we've moved into this green building initiative, where we've tried to make our buildings extremely efficient, keeping energy in or keeping energy out, primarily through the use of metallized windows. Unfortunately, metallized windows they tend to keep heat in or out. They also tend to keep radio in or out. And so it's becoming more and more common that building codes are requiring public safety to test performance in critical locations. So as new shopping malls are put in or new skyscrapers are put in, for example, in Sacramento, California, the capital, they've begun to require that critical buildings be tested to make sure that when the police go in to that building that they're not in a radio dead zone. And this trend towards requiring this as part of building codes is only going to increase. Also, some folks have, because of the economy and because of the challenges towards making the migration from 25 kilohertz analog to either narrowband analog or narrowband digital, because this involves a capital expense, there's certainly been a proliferation of modifications to radios, kits that people can apply towards their existing radio system. One of the problems that we get into with narrowbanding kits is that the performance of the radio then needs to essentially be recertified or reconfirmed, and things like filtering may not be sufficient for adjacent channel interference or to deal with interference issues that may crop up. So if you're using a narrowbanding kit, you want to make sure that your radios are performing. And also, of course, you want to make sure that you don't have an issue with spurious emissions that could put you in violation of the FCC, and that could result in liability and fines. People are also reusing and retuning antennas and combiners or filters and trying to make these cost-effective moves during the narrowband migration. You want to make sure that these things are performing up to snuff to give you the performance that you need for the radio system to work. So we'll talk now about test solutions to address these failure causes. So during the poll, one of the things that we saw was that a significant portion of the poll responders said that outdoor coverage mapping was a challenge, and that tracks with what we believe to be one of the major issues. Outdoor coverage mapping, as we talked about earlier, is defined by the TSB-88 methodology. We recommend, however, that BER-DAQ metric be supplemented with modulation fidelity or error vector magnitude to make sure that we address multipath. Indoor coverage mapping is increasingly a challenge, and you may find that your local laws begin to require that if they don't already. One of the major radio manufacturers currently recommends a two-stage analysis approach to indoor, and so what they recommend is to map the perimeter of the building to get a sense for where the shadowing is occurring, where the radio signals are going to be weak on one side or strong on the other side of the building. And then once you have a baseline perimeter, then to map the interior of the building. One of the documents that's being developed right now to address indoor coverage mapping is known as NFPA 1 Annex O. And that NFPA 1 Annex O addresses the question of how do you test inside of a building. So NFPA 1 it's analogous to the TSB-88 in the sense that it mandates a gridding pattern. It recommends testing in an X pattern on approximately a 10-foot by 10-foot grid, which, as you can imagine, is not easy to do in a working environment where you have people and furniture and existing tenants in the building. Certainly at the commissioning of the building after it's been constructed, you can go in and do that, but then they recommend a yearly retest, and once the building is occupied, it's going to obviously be very hard to do that. Some folks have used what are typically called carts or instrument carts that are spectrum analyzers on a rolling cart. In some cases, a lot of cases, this is not a viable solution. You're not going to be able to wheel a cart through the middle of a densely occupied office and get into places where you're doing, as you can see here in the grid, in this 10 by 10 grid, you're taking a significant number of points. This 12 to 13 points here in this, just in this 10 by 10 area. So portability is obviously critical. Spectrum clearing or interference analysis is also something that is critical. In doing spectrum analysis, you want to make sure that you're using a device that has a good dynamic range. You don't want nearby strong signals to overcome the spectrum analyzer and and shadow near small signals that may be within the passband. So having good dynamic range and low phase noise is critical to avoiding issues in cases where you have nearby blockers. We also have spectrogram analysis is important to be able to record and analyze over a long period of time. So you may find that your interference sources come in at certain times of the day. They could even come in at times, say for public safety, where the police officers might report that they're getting interference at 2 o'clock in the morning or 3 o'clock in the morning. And there would be a time when you don't necessarily want to have a technician sitting there with his finger hovered over a spectrum analyzer waiting to capture a trace to figure out what frequency the problem is coming from. So being able to record and analyze, store that information for later analysis or offline analysis is critical. Also being able to store the spectrum baseline so that you can go back a couple of years later and look at it and determine that, hey, look at this, 2 years ago we didn't have a problem at this frequency and now all of a sudden we do have a problem. So these are things that you want to make sure that you have available to tools that are critical for doing spectrum analysis. Being able to set limit lines, do max and min hold are also important. Actually, it looks, sorry, I jumped around a little bit here and I apologize for that. So being able to set a limit line, here what we're looking at here is the display of a spectrum analyzer, and this green limit has been created automatically across the top of this signal. And then we have, we can set up what's called save on event, which means that if the signal exceeds this limit, that it will automatically record to memory and store that trace away. So being able to do this avoids having to be there at 3 o'clock in the morning waiting to capture that critical event. If you've purchased radios and you're trying to narrow band them, you certainly have to go through an alignment process on those. If you've put in narrow banding kits to existing radios, you want to certainly make sure that you're within the FCC spectral mask for Part 90 to make sure that you're not in violation. So you want to make sure that you have access to tools that can tell you quickly whether or not you can be assured that you're within that spectral mask compliance. Every digital system, whether it be P25, NXDN, DMR, or Moto Turbo, has its own particular metrics for performance, and you want to make sure that you can test both the receiver and the transmitter of those radios. So certainly radio alignment is something that you have to do on a regular basis, and the proper tools for that are critical to making the system work. If you have a repeater site that you're working on, you have a lot of tasks that are required to do with the repeater site. Being able to build or to tune combiners and filters requires a high dynamic range vector network analyzer. cable and antenna analysis for doing distance to fault. And one of the ways that people tend to do distance to fault is by using what's called a TDR, a time domain reflectometer. The problem with a TDR is that it has a certain periodicity in its frequency response. And so you can have issues where an impairment in the cable can be showing up at only certain frequencies, and it may be that that impairment shows up at a frequency that the TDR is blind to. So we want to make sure that we're not dealing with any issues that are being shadowed by the TDR, and so frequency domain reflectometry is one way to do that. And what that does is that it sweeps the cable with a constant amplitude signal, and then is able to report those issues that are occurring at that frequency. And by mathematically converting that into distance, then we can identify exactly where those problems are occurring, and then go and look at the cable at that point. Also, intermodulation is a challenge at repeater sites, especially if you have a lot of transmitters that are co-located. Things like rusty bolts, people that have repaired a tower and put stainless steel bolts on a galvanized structure. When those junctions corrode, they create diodes. Two very strong signals can mix and actually produce a third, so it acts as a passive radiator. And so being able to do spectrum analysis or spectrogram analysis and detect high-level intermodulation are critical. Obviously, you want to make sure that when you're commissioning a radio system at a repeater site that you're not dealing with channels that are impaired in some way, that there's not something that's causing interference that's going to degrade the performance of the system. So spectrum clearing, channel clearing at a repeater site is critical. And being able to do repeater and radio alignment at the site is also something that land mobile radio technicians and engineers do pretty much all the time. The problem is that a lot of these sites are located in places that are very hard to access. So we're dealing with, in some cases, repeater sites that require, they can't be accessed via vehicles. There are some repeater sites up in the Sierra Nevada mountains in California that are only accessible by ski lift. I've worked with some customers that have repeater sites that are only accessible via helicopter. Being able to get your test equipment up to the site is certainly something that you want to have available to you, because you don't want to be lugging 45 pounds of gear plus whatever connectors and coax and such tools that you need to bring up. So if it takes you an hour to get up to the site, you don't want to have to make repeated trips because you're carrying too much weight. Another critical activity that often occurs in commissioning sites is building phased arrays or constructing combiners, and being able to construct cables that are of a very specific length is critical. I just got an alert, Jeff, on my screen about network connectivity. I just want to confirm before I go any further. Is everyone still able to see me? Am I having trouble getting through?
I'm all clear on my side.
Jeff? Okay.
I'm good here.
So being able to create precise electrical length of cables for creating these phased arrays and combiners is important. So of course the question becomes is, how do you do all of this in test equipment? What are the solutions for solving these problems and for being able to do the tests and measurements that I've discussed previously? And the answer from our perspective, of course, is the Anritsu S412E LMR Master. This is a portable test instrument. It combines the best capabilities of the SiteMaster, which Anritsu is well known for in the industry. It's the industry standard for portable test equipment for cable and antenna measurements. It also combines the functionality of a Spectrum Master, which is an instrument that you all may also be familiar with. It adds in a signal generator and the ability to handle the various modulation formats for digital and analog LMR. So it does P25, it does NXDN, it does DMR Tier 2, Motorola calls that Moto Turbo. And we have added in the ability to do LTE. So we've had this capability going back a year. When we first rolled the instrument out, we came out with LTE because we saw that the instrument was, or that the industry was moving towards public safety LTE, and we were right in making that estimation. So recently the payroll tax bill was passed, and the $7 billion allocation for public safety LTE and the what's called the D block was passed. We also have added in WiMAX because there are some cases where people are using WiMAX for a backhaul. We have the ability in the instrument to do coverage mapping without a PC, so the instrument can map analog or digital land mobile radio. It does not require any external computing. It maps directly on the instrument. The results are displayed on the instrument, but they're also able to be transported off the instrument to a PC for offline analysis. We do export that coverage data in a text format as well. So if you have propagation prediction programs by, for example, EDX is a vendor, and the EDX software is capable of taking our coverage so that when you predict the coverage using EDX, you can then put our coverage files back in to confirm that the predictive model matched the real-world results. Our spectrum analysis capability, we have a minus 152 dBm displayed average noise level with a best-in-class phase noise performance on our reference oscillator. So our spectrogram our spectrum analyzer and spectrogram results are not influenced as strongly by local interferers. So if you're working at a repeater site, you do not have to worry as much about the fact that local transmitters, strong transmitters that are nearby, are going to be affecting your results. And we have the ability to put masks and limit lines to do offline capture and recording to be able to analyze the spectrum performance or the spectral mask of a transmitter. The instrument also has a 100 dB dynamic range vector network analyzer with distance to fault analysis using the frequency domain reflectometry technique that I talked about previously. And we do all of this on a 7.5-pound device with a color touchscreen and a 3-hour battery life. I see that I have a question here in chat. I'm going to go back to that slide. So before I guess at this point, Jeff, I'll hand it back over to you, and we can open it up for questions.
Okay, thank you, David. Before we open to questions, I'm going to open up a second poll so that, and again, remind everyone to please submit your questions. We do have a number of questions in, and we have another number of prepared questions that we're going to ask, but please take a few minutes, if you would, to answer the poll that I'm about ready to launch. So again, it'll give us a better sense for the audience and the type of questions that you have. Do you plan to migrate either to digital narrowband or analog narrowband? We'll keep this open for roughly 30 seconds to 45 seconds. And again, remind people to please submit your questions online. Other admin items, this webinar will be sent to the attendees within 24 hours of the conclusion of today's webinar. We will also have it up on the website, rcrwireless.com, and under the webinar tab, and we'll have that up within 24 hours of today's webinar. If you have an interest in sponsoring a webinar in the future, please give us a call. One of the things we've launched this year is a series of editorial webinars that we do after the major trade shows, so that folks who don't have the opportunity to travel can certainly participate in those editorial webinars. We did one at the end of the Consumer Electronics Show. We hosted an editorial webinar with Dan Meyer and two analysts after the most recent Mobile World Congress show. We'll be covering the Rural Cellular Association event coming up at the end of the month, and we'll have a post-event webinar there as well. So we've got just over 50% of the attendees have responded to the poll. So David, I'm going to leave it open just a minute more. But go ahead and I'm going to go ahead and ask one of the questions that came in. Does the S412E support the same SiteMaster software, or has it been updated?
Okay, thanks, Jeff. That answer, it requires a couple of explanations. The SiteMaster software has traditionally been what's called handheld software tools or line sweep tools. We are moving towards standardization on line sweep tools, and because it's important to remember that the S412E combines both the cable and antenna vector network analyzer capability with spectrum analysis. So when we're talking about software, the line sweep tools are related to that cable and antenna vector network analyzer analysis. So the answer is that it has been updated. We are releasing support for the 412E in line sweep tools very shortly. Master Software Tools is the package that we use for spectrum analysis, post-processing, creating movies. For example, you can create a 3D visualization of spectrum. You can create a movie of spectrum traces that have been captured over time. So I talked earlier about that offline processing of spectrum results, being able to capture 72 hours worth of data and then replay it or look at it and post-process it. That's all done through Master Software Tools. So depending upon what you're using the instrument for, there's a toolbox for each function.
Okay. Another question that came in: are EDX coverage files compatible with the coverage mapping option?
The answer is that EDX has built support in their software for taking our coverage files in and working with them. So yes, if you contact EDX and you have the latest version of the software, you can take the coverage files back into EDX and analyze them in the EDX package.
Okay. Will this instrument do return loss measurements?
Absolutely. So return loss is a basic function of the vector network analyzer. We have two user interfaces in the VNA. We have the cable and antenna user interface, which does return loss and insertion loss. And so if you're familiar with the SiteMaster, you're going to be very familiar with the cable and antenna mode in the S412E. If you're looking for more sophistication in your measurements, you want to do VNA measurements using scattering parameters, you can change the GUI to be a full VNA GUI. And so depending upon where you prefer to work or what sort of tasks you're trying to do, the instrument is adjustable to suit your operating style and the things that you prefer to look at. So the short answer is yes, we do return loss measurements. It's important to note that the VNA and the S412E is a two-port, one path. So it also does insertion loss. It's capable of doing both return loss and insertion loss.
Okay. Craig Given from the audience asks, can the LMR master handle TSB88 based tiling for service area testing?
We are currently not capable of doing TSB88, although we are hoping to work with manufacturers, software vendors that do TSB88 tiling. Currently, we work with EDX, and perhaps in the future, EDX will be adding TSB88 capability, and if so, then our results would flow back into that.
Okay. And then is a S332D capable of doing narrowband checks in an efficient manner? And that question comes in from Richard Yates. Thank you, Richard.
An S332D is an older SiteMaster, and so the older SiteMaster is simply a cable and antenna device. It is not intended for narrowband land mobile radio checks. So I'm not quite sure, Richard, if I understand the question. Are you talking about cable and antenna checks of narrowband, or are you talking about being able to actually analyze narrowband FM signals? And maybe you want to re-ask the question, and we can come back to it, Jeff.
Okay, perfect. We'll see if Richard responds there. I'll move on to the next question. How can we get a description of the Anritsu file format?
Which file format are you referring to, Robert? There are several files that emit out of the S412E. They could be everything from VNA line sweep files to spectrum analysis files, or coverage mapping files. So I think I need a little bit more. I think I need a little bit more information to be able to answer that question correctly.
Okay.
Coverage mapping files. Okay, I see that Robert just popped up here with coverage mapping files. You would be able to get that from Anritsu.com. So if you just go on to www.anritsu.com, type in S412E to the product search box, it'll take you to the product page. And if you go into the manuals or the library tab, you will see a measurement guide, what's called the Land Mobile Radio Measurement Guide. And within the Land Mobile Radio Measurement Guide is contained the information on the file format for coverage mapping.
Okay, next question is what is the fundamental difference between the Anritsu talked about here and the MT8221B?
The MT series analyzers are cellular analyzers, so we have products that are specifically targeted at doing cellular. The LMR Master is intended for use in land mobile radio. So the MT8221B would be focused on cellular protocol testing, and the LMR Master is focused on land mobile radio protocol testing. So for example, that instrument would not do narrowband FM, it would not do P25, NXDN, DMR, Moto Turbo. None of those protocols are going to be in the 8221B.
Okay, next question is the equipment capable to perform noise figure measurement?
It is, unfortunately, we do not have for the VNA a noise source. There is some discussion about adding noise source capabilities, but currently today we do not have a noise source for the VNA, so the answer to that would be no.
Okay. When analyzing narrow-banded radio outputs, what is the power handling capability?
So because of course it's a portable instrument, we're trying to keep the weight down. We have not put internal attenuator or internal loads inside the device. In the cellular world, this has never been an issue for the operators there. They simply put attenuators in line. So we've matched that capability in the S412E. We do sell a line of inline attenuators, which are sufficient to knock the power down. The answer is that the rated input of the RF in is 2 watts. But if you put a 30 dB attenuator on there, then you won't have any problems with that.
Okay. Next question, can the Anritsu spectrogram, I'm not sure, can the be logged against GPS during a drive test? I'm not quite sure I understand the question. Does that make sense to you?
Yeah, I think Craig is asking the question, can the spectrum be tagged with GPS? And the answer is yes. That's exactly what we do in the coverage mapping function. We have the ability to do coverage mapping in the narrowband FM application for RSSI, transmitter SINAD, or THD. And when you set the instrument up with the GPS, you are mapping those points. So I want to go back here in my slides, and I want to show you here. So Craig, if you take a look at this display, you can see that what I've done here is I've mapped RSSI from the Anritsu offices up into San Jose, and the results are tagged with the GPS, and they're also color-coded according to user-settable levels. So if you look at this display here, you can see that we have everything from signals that are exceeding minus 70 dBm all the way down to signals that are down into the minus 100 dB range, and even below that. So the answer is yes, we do GPS tag results. And I probably ought to mention that for indoor, we don't use GPS. What we use is the touch screen of the device to do either a tap and walk measurement, or we can do a tap on location measurement. So as you can see from the screen down at the bottom there, the screenshot showing the interior of a building, what we've done is we've placed a transmitter in one part of the building. I think we were actually measuring the performance of a Wi-Fi access point, which was on one side of an interior, rather it was on the outside of a meeting room that's in the middle of the building. And you can see that on the left-hand side, let me get a spotlight here. You can see that over here, it's very strong. And as you move around to the other side of this internal structure, it becomes very weak. And what we did was we start measuring here, we tap on the screen, and we begin taking measurements, and we walk. And at the end of the walk, we tap again, and the instrument interpolates the measurements across the corridor that we've walked down. So if you walk at a reasonable pace, it'll take a measurement about once every about 1 foot per measurement.
Okay. David, are there any options for P25 packet analysis?
We do analyze P25. We are capable of demodulating we can look at the control channel, and so we do bit error rate analysis, we do MER analysis, message error rate analysis on the P25. We can decode the control channel of the P25, and we can also do what's called an IQ capture. And so in cases where you're having problems, we're currently working with one agency that's having some issues getting one vendor's P25 to talk to another vendor's P25, and IQ capture has been a critical part of that debug. So being able to capture using the IQ and then taking that file offline for analysis using some scripts that we provide has been critical towards troubleshooting that issue.
Okay, I'm going to share the results of the poll, David, because I think they're
great.
pretty interesting. 6% of the respondees intend to request a waiver and do not plan to migrate. When you look at those results, David, how do they compare with some of the feedback you've been getting from customers?
Well, I'm a little surprised by that because during the registration process for this webinar, we asked the question, have you already migrated, or are you still pending migration? And I think as I recall, only 20% of the respondents had said that they had already completed their migration. And of the ones who hadn't migrated, a third indicated that they had that they didn't think that they would make the deadline. So I guess I'm a little surprised that that only 6% are intending to file a waiver, because I don't know what the rest of those folks are going to do come January 1st, 2013. You know, the government Congress has talked about possibly extending this narrowband deadline, and certainly there are some complexities that have come out of the recent payroll tax bill which might indicate that an extension of the narrowband deadline would be in order. But to date, nobody's said that this is something that they're going to do. And so I would caution everybody to, you know, keep an eye on what's going on, because as of today, there is no waiver and there is no extension of the deadline. People have applied for waivers, and in some cases they've gotten them. But you know, you don't want to be really sad come January 1st, 2013 if Congress does not move forward on an extension of this deadline. You've only got, you know, a few months to complete this, and as you can see, there's a lot involved in making this migration. So don't wait until November 31st to do this.
Okay. Well, speaking of legislation, how, if at all, does the recent passage of legislation which allocates the 700 megahertz D block to public safety affect the narrowband deadline?
Well, one thing that came out of the payroll tax bill and the legislation that allocated the D block to public safety, and this would be used for the public safety LTE for the data network, was a requirement within that legislation that public safety give back frequencies in what's called T-band. And what's a little strange about that is that it only says public safety has to give back the T-band channels. It does not talk about any commercial occupants of the T-band. So, you know, of course, it's an 11-year deadline. There's 9 years to make the transition, and then another 2 years for people to complete it. So we're talking a decade from now as to whether or not people are going to have to do this. But if you look at it, you could say, well, all right, I'm in a commercial vendor or even a public safety commercial occupant licensee or a public safety licensee in the T-band, and you're telling me today that I got a narrowband, but then 10 years from now you're going to boot me off those frequencies. So how does that work, right? And those people are probably going to be in a position of saying, hey, look, I'm going to ask for a waiver because I don't want to have to replace my system and then a decade from now turn around and replace it again. So I think that there's a little bit of uncertainty because of the way that the bill was written. And I guess I wouldn't be surprised to find that the current administration may decide that they're going to extend this narrowband deadline. But please don't take what I've said here as permission to not narrowband. You know, as of today, you still got to do it. So, you know, keep an eye on what's going on. If you're going to file a waiver, file a waiver. But don't take this as carte blanche that you don't have to narrowband, because as of today, you still do.
Okay. We got a few minutes for some extra questions to come in, but I do have some I want to go through quickly, David. Earlier you were showing a diagram of indoor testing and coverage mapping, and in some cases, in some areas, it's required by law to do coverage mapping indoors. Are there published guidelines or standards on how to perform these tests properly?
Yes. The NFPA 1 Annex O is the currently accepted guideline that is typically being legislated. So the methodologies that are outlined in the NFPA 1 Annex O are the methodologies that you want to follow. They dictate everything from how often should you test a system to how often should you retest a system, what are the criteria for performance, How do you take an interior space and divide it up into a set of squares and then go in and test those squares? And so the NFPA 1 has been a source of great guidance, and it's becoming increasingly important. In some countries, it's actually required by law. Like, for example, in the Netherlands, it's required by law that all public spaces need to be tested for coverage by public safety radio, and we're beginning to see that here in the U.S. as well. So it's increasingly a requirement. I think cases like JFK International, where we had a brand new building that suddenly didn't work for public safety, show us that we do need to do this. And so I'd encourage everybody to become educated on how NFPA 1 dictates internal coverage mapping, because it's something that you're going to have to know in the future. I can guarantee you that within a decade it's going to become critical.
Okay. I'm going to wrap up with one question before we run out of time, but would you mind moving your presentation to the last slide? I think you had some contact information there, but I guess the one question was asked repeatedly throughout the session was, what would pricing on a device like the S412E test set be? How do you respond to questions about pricing?
I would suggest that folks either contact their Anritsu sales rep if they are already working with somebody, or call 1-800-Anritsu, and we'd be happy to talk to you about pricing.
Okay. Well, David, you can see the questions, same things that I can. Do you have any closing comments?
Let me take a look at the questions here. I
think we got through most of them.
Yeah. Can the LMR master measure data be changed to predict potential loss before actually going? Yes, a question from Joe Watts. Hi, Joe. If you're the Joe Watts that I think you are, hello. And the answer is yes, you can take the measured data from the 412E. For example, if you currently have an analog system in place, you can coverage map it to determine where your RSSI boundaries are. And based upon that, you can go back and then you can set up a test system for, say, P25 or NXDN, and you can go do bit error rate, modulation fidelity, EVM testing, and then lay those two plots on top of each other, and you can see where the problem areas are going to be. And so what you're typically dealing with in cases like this is your users have an expectation of where they may have what's sometimes called scratchy or fuzzy coverage, and you don't want to send people out into the field with digital radios and have those turn into dead zones. So if you have the ability to map the analog system, that'll give you a good idea for where the users are going to have expectations about performance. And then when you take the P25 or the NXDN coverage data and lay them on top of each other, you'll be able to see very clearly where the coverage has changed, and you'll be able to then decide, okay, I need to extend my power, or I need to use directional antennas to compensate for those areas, or you may have to move around your if it's a simulcast system, you may want to move your architecture around a little bit and focus coverage in different directions to solve that problem.
Okay. Well, we're out of time. I do want to thank you, David. Excellent presentation, and I want to thank everyone for joining us. Presentations will be sent to all the attendees within 24 hours. They will be available on the website. We have documented, there are some other questions that came in. We've documented those, and Anritsu will have those and be responding to folks directly. So again, thank you for participating today, and have a great weekend. Bye now.
All right, thank you. Bye-bye.
The organizer has ended the session, and this call will